As with any logistics process, preparation is a key element. Prior to laying out a warehouse, deciding on the most appropriate handling equipment, installing storage systems, and deciding on which form of picking system to introduce. A full ABC analysis of stock movements and stock held should take place. Understanding ABC classification begins by understanding Pareto's law, or the 80-20 rule. This states that roughly 80% of the effects come from 20% of causes. This rule is not universal, but it is surprising how often it can apply. The idea is then to concentrate time and resources on the important 20%, or the vital few. Pareto's is widely used to logistics, and it's an excellent method for categorizing items. This normally called an ABC classification. Many companies will use ABC analysis to produce an effective warehouse layout. However, the traditional single ABC analysis will only provide a snapshot of the current situation based on one parameter, the level of sales by product. The idea being that A items is the highest sellers are placed in front of the warehouse closest to the dispatch area. Unfortunately, using this analysis standalone can lead to a reduction in productivity. For example, compare the following two products. Although product A is the highest selling item, it's only picked 4 times during the period, while product B appears on 200 orders requiring 200 visits to the pick face. Under these circumstances, in order to reduce travel distance and time, it is product B that should be closer to the dispatch base. It is our contention that the picking area layout should be based on the number of pick face visits, taking into account size and weight of the product and any special circumstances such as high security items. For those who want to take quantity into account as well as pick face visits, a double ABC categorization will allow you to combine these two factors into one, in this case, volume and frequency. This can be done by producing a 9-box grid as this one. In this example, double A products are those that generate the most sales and are sold most frequently. Double C products, on the other hand, are defined as slow movers in that they sell the least and move less frequently. In terms of picking, the more frequently you visit a pick location, the more labor intensive it is likely to be. Products in position double A will generate on average 50% of your sales, yet will only be 8% of your product range. This figure here shows the relationship between the frequency of sales and the value of the product. As you can see, different strategies can be introduced for each of the sectors. These can include factors such as service level provided, stock order frequency, method, stock counting frequency, and customer and supplier relationships. There are sophisticated software programs available to enable you to produce these results. However, if you are looking for a quick analysis, utilizing the sort feature in Excel will give you reasonable results. Another part of the preparation process is slotting. This is a tool that calculates the optimum location for products within a warehouse. The tool is used to reduce the amount of travel time for operators by not only placing fast-moving products closer to dispatch, but also places items that frequently ship together next to each other in the pick face area. For instance, in a maintenance store environment, the natural storage method for nuts and bolts is likely to be family and product code, all the nuts in one area and all the bolts together in another area. Although reasonably close by, our suggestion is that the same size nuts and bolts are stored next to each other. This is for 2 reasons. 1, they are normally sold together, and 2, it provides a separation between 2 similar sized products. This should lead to a reduction in travel time and potential errors. The system can also identify small groups of products that can complete a large number of orders. By examining the popularity of the items combined with the orders that they complete, these items can be identified and stored within a specific area of the warehouse. Slotting can also determine how many and what size of pick face is required for each product line. Very fast-moving lines will require multiple faces to avoid a bottleneck at a single location. This needs to be spread efficiently across the front of the racking near at the start and finish of the picking run. Slotting will also take into account seasonality and suggest product transfers, such as moving garden furniture from the front of the warehouse where it is stored during spring and summer to the rear during the winter. The system can also take into account other parameters such as value, cube weight, and crushability. Retailers can also set up the system to pick and sequence tailored to store layout in this way, minimizing the time spent handling the product at the store. This software is integrated within many of today's warehouse management systems, but can also be sourced separately. By profiling the activity of items and orders received into the warehouse, we can determine which pick method to use, how much space to allocate, and therefore where and how to store the product. The idea is to place the most popular items in terms of frequency in the most accessible warehouse locations. The amount of space made available to the pick operation will very much depend on the total available cubic capacity of the warehouse, the floor space, and the amount of reserve stock needing to be stored.